this morning, who's IBM's lead engineer with virtual machine space. He's CTO for division. He's been joining running on the division area since day one, since they had virtual machine strategy. And John's going to tell us where things are going to go. Thank you, John.
Thank you. Thank you. Oh, don't stop. Don't stop. So, who's heard of Java? Just checking. Who's heard? Who knows what Java is? Oh, good. I can skip a few charts. Good. I just wanted to make sure because I don't have robots. So I'm pretty much screwed. I can't really impress you with flying torturous machines or something. But I do. That's the only time in my entire life I've looked that good. So I put that everywhere. So I'm really old, so I have lots of experience, and I do JVMs. And because I do JVMs, I have an opinion that is probably a little bit different than most people, because I have to deal with most people's code. That's like being the garbage man. I have to pick up the trash at your street. And let me tell you, we see some pretty good stuff. So this is how I got you here. The 2,000 people for the record in the audience. Let's just put that on tape for later. But I wrote this and I said, yeah, I should talk about this. And you guys fell for it. Actually, what I decided to do is simplify a little bit. I'm going to talk a little bit about Java, OCI, and the ecosystem today. And we're going to do some mocking, because that's always fair. Technical people, if you get into technical discussion in the crowd or outside or in a bar, usually someone mocks some piece of technology that you're all familiar with, so it's kind of like this thing that you love to hate, so we'll do some of that. Of course, after the mocking and you're all in despair, we introduce hope. So it's a roller coaster day. And after that, we all go, oh wait, more, hope. After that, we go profit. We go and take our newfound knowledge and our better runtimes and go make trillions of dollars. Right? All right. So it's Java today. Pretty mature. It's reliable. I heard it's reliable. I have to look at this because it's got great tools in the Eclipse Foundation and the tools being built within it, including the runtimes. Great. Has other developer-friendly ecosystems like Apache. So you know all this. It's perfect, except not really. Now, this is Bitterboy. He's the J9 VM team counterpoint. If there's a bad thing to say about something, Bitterboy will say it. Now, Bitterboy is actually based on a J9 JVM team member, and there's actually Bitterboy's creators right there. Put his hand up later or now when he has a chance. There he is, blame him. But there's an actual, it's not him it's based on, there's someone else it's based on. And he's actually that bitter. So he says Java's not perfect. Surprisingly enough, it's not. There's lots of things we could do to it. But that character right now is the lead architect for the J9 VM team. So if you know who that is, that's who that's based on, and he actually has opinions about this. So he's here to keep us on track today. So, developers. You guys are all developers. I'm a developer. Big challenges, okay? Coding today isn't like coding even 10 years ago. There's a lot of new things happening. So the list is, IBM first has to start with a cloud thing. So cloud stuff. But cloud is, it's not just a buzzword, it has technical implications. The fact is you're going to be virtualizing your applications, you're going to host them on some service somewhere, and that person is trying to eke out every erg of CPU for as many people as possible, driving performance into the ground potentially, or giving you unpredictable performance. And so there's a lot of dynamicism in cloud runtimes. There's a lot of pressure to push density in cloud runtimes, so cloud is a big deal. Big star.star. Okay, you'll see this week, I've seen some already, talks on Hadoop and other things to deal with large amounts of data. The amount of data people are dealing with is significantly larger today than ever before. And there are techniques that are being developed, like the Hadoop, where you slice and dice across a scale-out set of machines to deal with this data, okay? And, it's no longer, read from a database, update a record, and stick it back. You might have to be dealing with petabytes or more daily in some cases, okay? Security is a huge problem, and everything's connected, so everything's at risk. And, Java takes, great pains to be secure, and we spend a lot of time, talking to security researchers who spend a lot of time trying to break security, and we fix these things. So it's important, but I think we should take a look at what else we could do and make security better. The last one is compatibility plus the extras, but compatibility is one of the key values that we need to protect in Java. You've invested lots, your code should continue to work, but how do we blend that with innovation? So we'll have to talk about that. And then there's a list of things like better development efficiency, mobile, life cycle, all sorts of stuff, okay? So I think we need to talk about Java evolving to solve some of these problems, this complexity. And then here today, I'm going to talk a little bit about Eclipse, OSGI, modularity, how they can help solve these problems, okay? So, the Java platform. You guys are probably familiar with this. And so, I'm not going to take you through it. You've probably seen the 2011, 2013, 2015 modularity, has moved to 2015, but you've seen this kind of roadmap. So if you show this to some people, they go, yeah, Java's evolving, it's really great. Look at all this good stuff. And there is good stuff, right? So in 2015, another year, you'll get Java 8, you get some SC profiles. So the question, depending on who you ask, is this innovation too fast, fast enough, just right, too slow? And simulating too fast here is my friend Mike Milinkovic in his Porsche Cayman. Driving a little too fast, there's simulating slowness is Mike Milinkovic's pet turtle. The car is actually Mike's. The turtle is just something we saw in Raleigh. So my claim is that we're not innovating fast enough. We have a list as long as this huge screen of things we need, okay? Things we need in Java to solve particular kinds of problems. So Java itself doesn't support things like within the JVM, within the runtime, managing resources, okay? Saying, I'd like this component not to use too much memory. I'd like this component not to use too many sockets. So if you try to do things like create a modular piece of software, you might want to have a little more control about the modules you're loading. Java doesn't give you that. So those are the first 2 points. Runtime resource control scoped by module as one option, or scoped by some sort of context. And so wouldn't you like to be able to write some code and say, this code I know is not going to make a thread. You're not supposed to make threads. I'd like to make that part of the contract. I'm going to spank you if you make a thread. And don't be thrilled by that last one. It's just punishment, in case you're wondering. So things like language extension for primitive types. The base primitive types are the ones you know and love. Int, byte, word, float, blah, blah, blah. But what about GPUs? What about color values, 565? What about really, really, really wide packed decimal or really, really wide floats? The language itself has been basically stuck with the initial set of primitives for a long time. And if you want to drive to new platforms that actually support some of these things, you don't have a great choice for Java. So evolving the language there is important. And I could talk about this whole chart for 2 hours, but I won't. Parallelism is important. So there's a lot of people writing parallel code, fork, join, those kinds of things. There's a lot of people hacking. So Martin Thompson just posted a blog about how you could hack the living daylights with external memory unsafe to go faster. These are the guys in the UK who do the disruptor message passing stuff. Completely insane that you have to do this. It's like you might as well drop into C code. That's what he's writing. And it's really bad because eventually it's going to break. And it's certainly not portable. So Java needs to be able to deal with that. Who writes J&I code? Who hates the fact that JNI is not fast? Because every research project we have goes, oh, we hack some stuff in C, then we call it from Java. And the #1 research problem is make JNI faster. Not the stuff on this side, the stuff on this side. It's the fact that you got to sort of walk across the thing and take a JNI call, right? It's like a relaxing protocol or something. So it's kind of a reified generics. That's so that your generic code works on ints and base types. And then true lambdas, not because Java needs it. Don't get me wrong. Java doesn't need true lambdas. But all the functional languages that people are bolting on top are going to suffer because there's no true lambdas. So lambda's coming, but they do things like capture variables that are called essentially final, which means you're not going to write to them after you capture them, which means you get a copy. So that's great if you want to make sure no one's capturing a variable that might be shared across multiple process or multiple threads. And for fork join, it's a great solution. But if you're writing a Lisp machine, closure, anything real with actual lambdas, even small talk, come on, where's the cheer? Woo, small talk, right. You're kind of hosed, and you're going to push your variables into the heap, and then once you do that, your performance goes into the floor. So, large arrays. Who wants an array bigger than 4 gig? Or sorry, 2 gig indexable multiplied by the size of the element. But who wants bigger arrays than 4 gig? Who says I'd like a 80 gig array? Well, our customers do. They call us and how come I can't make an 80 gig array? And you're like, you have to be nice, but you want to ask, well, what's in there? And there's some things that need that much. And if you're going to deal with big things, and I know not everything is that big, you need a unified model for doing it. You don't go, oh, I got to chunk up after 4 million elements or 2 million elements unsigned. So, and 200 other things. And if you have something that's not on this list, I'm sure we've heard of it, but come see me and say, put it on your list, please. You can argue about the list, you can add to the list, you can delete the list, but we're not going to talk about it that much more. We're going to focus a little bit on modularity today, okay? Because I think it's important for software engineering, and I think it's important for, it's important for me to be less confused. It's important for software engineering, it's important for functional enhancements. So, what do I care about? Modularity is one of those things. Why? Simplicity. Our customers care about simplicity. We're not here, well, I'm here to do really cool stuff in the JVM, but customers want to hear about how they're going to solve their problems easily, right? All the new technology you push down their throats is, if it's not consumable and simple, you're going to have very unhappy customers. So, I care about performance. I care about cloud. That's a mandatory. Notice it's in a cloud. And I care about software engineering. So, we're going to talk about Java for cloud, and I'm going to say some innovation required. It's like getting toys with no batteries. So, it's not a product placement. I'm sorry to put this in here, but deploying software into the cloud is complicated. It's not just run Java minus blah and hope everything works. There's databases to bring up. There's your application. So in here, it's WebSphere application server, but it could be Jetty, it could be Tomcat, it could be whatever. It doesn't really matter. The point is, you got to stand up an app server, you got to stand up a database, you got to stand up a ID server. All these things have to happen, and it's currently kind of hard to deploy into the cloud. There's no thing as like an ECE for the cloud, right? So the pattern approach, which is now starting to see people standardize these things, is starting to be thought of as the way to deploy. It has to have a full description of what you have to bring up and where, qualities of service, and these things are from best practices of the last 15 years of people deploying into these private clouds that now become trendy to call public clouds, okay? Why did I put this on here? The thing you need for here, and the thing you need for Java, so I'll just go to this one, is give something your application, say, please deploy this, cross your fingers, and it gets deployed. What's this thing going to do? It's going to rummage through your code, or look at your dependencies, or look at the modules you use, or look at the components you reference, and it's going to build you exactly what you need to go to the cloud. Otherwise, it has to take everything, because it doesn't know. So we'll drag in EE, you might need that, drag in some other WAD, and all of a sudden your deployed load becomes a gigabyte when it's really only a few hundred megabytes, okay? And the efficiency of deployment is directly, in many cases, driven by the fact that the size is big, okay? So if you can't actually even introspect your application. So OSGI, for example, you know what your dependencies are. So you would actually go, here, I'm going to deploy this, and what else do I need? Now, OSGI does it a little bit more dynamically, so you just throw the first thing and it'll get other stuff dynamically. But if you're going to have a lot of these classic systems, you need to be able to run the dependency analysis to do fit-for-purpose builds, okay? So that's why the connection, from my perspective, is things like OSGI will help us deploy more optimized applications. And if we optimize OSGI, the world gets better. So why am I doing this? I promise not to take you through this whole thing. But in the list of, this is a slightly squeezed chart because of the 16:9 conversion, but in the list of the kinds of things we're trying to do, we're all familiar with 1 gig deploy, 4 gig memory, take the whole box. But are you familiar with 10K per application? Well, there's extreme multi-tenancy use cases where you just can't stand up a JVM and you just can't stand up a whole operating system hypervisor combination to deploy your app. You can't afford it, okay? So we're trying to solve the wide range that you see here from mission critical apps. So banks are probably gonna have a separate full stack in many cases for certain things. They're not gonna go and share with the guy running the payroll, HR, register a new employee app, right? They're probably gonna keep you away from that machine. But if you're writing either free apps or plugins to another system, it has to be small. You can't just stand up a whole JVM and say, here, you're running this little 10-line plugin, but you need all this other stuff. You need to be able to put a small component. So we're doing things across this whole space to optimize Java, okay? That's the point of this. And the things in blue, shared classes, that's a way for you to shrink JVMs within multiple JVM scenarios. And isolates is a way for us to shrink JVMs in multi-tenancy scenarios. And there's a few charts. So these are I don't know, words to live by and how we think about cloud. But I'm going to tell it to you differently. This is how we teach our children. Who has children here? Probably lots of you. All right. You tell your children, share more, share your toys. Well, in a JVM context, it's share your memory with other underprivileged JVMs that might be over here with starving for memory and you have lots of memory. Please give some of that over there. So share more, that's what you would tell your children. And all of these things you tell your children, okay? Cooperate, don't whack each other. If someone says, I need a little more CPU, step aside. I need to use the play jumbo set or whatever, share, or cooperate. Use less. Don't take all the cookies. Leave some for your brother. Anyone have kids who, you have to fight for your brother, with your brother for food? Me. Lick the thing, put your thumb on it, and it's yours. Anyone who has brothers knows exactly what I'm talking about. Anybody else is like, what the? Okay. Now you're wondering how the last one fits in with children. You get your children to make you iPhones in China. That's what you do. That's why that's all in there. So actually 3 out of 4 are legitimately used for your children. The last one, maybe I'll figure out a better story for how you exploit your children, but not now. However, let's talk about these in the context of modularity. Right? So the first thing is the use less. Okay? Use less, I talked about deploying an application with only what it needs. So we have a product, it's called Liberty. I'm not trying to sell it to you, but it's, for the OSGI folks, it's pretty obvious. It's a modularized server. And what you just get what you need. Now, why is that important? It's small, lightweight. So small, depends where you come from, 50 megabytes. May or may not be small, but it is fairly small for what this is. It's fast, starts up quickly. Why? It only starts up what you need. You're seeing direct benefits to customers. Their apps deploy quickly, the development cycle's fast. This thing actually has integrated Eclipse tools available in the marketplace, so you can just go and try it for free and all that stuff. What's this coming from? Modularity. The modularity that's being used is being used to deliver value. So you could say, oh, I love modularity because it's really cool. It is, But to customers, they probably don't care in general that it's really small and composable. They care that it's small and fast and less expensive to run and manage. And that's why we have to develop better modularity and improve it. Not just stop where we are. We know a lot about it. Let's keep going, okay? And the right size app is critical. If you have to buy, you know how they have tiering. The small instance is so many dollars a month. The next one up is a lot more. You'd like to be in the small one if your app only needs a small one. So this is actual value, money you save at the end of the month because you didn't have to drag in a bunch of other stuff. And how do you know what you have to drag in? Dependencies that your modules provide, okay? So it's composable. This is the way things have to be built and deployed. So let's just do some mocking. So we're smart. The whole room is pretty smart. I'm pretty sure everyone in here is uber smart. And so why do we, asterisks, do stupid things? No. We isn't us. Where we in this room is excluded from this. We is the other guys, the industry, which we are not at fault for. So that's number one. Now, as an example of a stupid thing, the other asterisk is put a chart like this in your keynote and potentially insult your whole audience, which is not the intent. So let's go talk about this. So OSGI, great technology. I should be down there and just watching this because it's, you guys would be like, ooh, yeah, awesome. So it's great technology. I don't actually, who knows what OSGI is? Do I have to tell you what this is? Everybody does. Is there anyone who doesn't? Ralph, you should talk to everybody else. Okay, so it has all this excellent stuff. It allows you to build this composable runtime that we've just talked about in actual products. We're not just using it for educational purposes. We use it. It has pretty much all sorts of app servers support it, tools support it. It's good stuff. I don't need to sell it to you. You all love it. But Bitter Boy is to the rescue because otherwise, if I said it's good, I could just leave, right? All right. So Bitter Boy doesn't believe it's perfect. Okay. So the issue with the issue is that OSGI was built in spite of Java. Okay? Not to spite Java. In spite of the lack of modularity support, OSGI built it anyway, right? And they built it with what you're allowed to use, things like, class loaders. So, Java does have basic modularity, so but classes and packages and slightly poor visibility control is kind of weird, but it's there. And there's no versioning information, so for serialization you could make one up, but that was just designed to break, so people hack it. But the issue, OSGI has had to work within the limits of the platform. So as a JVM guy, I'm here to tell you, OSGI could be better. We could do better, okay? So, and in order to do that, the only people you should talk to and trust, JVM guy. It's true. So, let's try to get some enhancements into the JVM, and I'm going to tell you why. It's time. Now, 6 months ago when I said, I'm going to do this keynote, I'm going to go, it's time right now, because Java 8 is about to have modularity. We had to do a lot of things to attempt to make sure nothing went wrong. It's a little bit more of a reaction thing. Now we have a little more time, so we can talk a little bit more about the kinds of things that it's worth adding to the JVM, okay? So, put your imagining hats on, children. What would happen if you had JVM support for modularity? And it wasn't just running a whack of Java code to load your stuff. You could have, I listed, instant on. So instant on means your Eclipse starts up in no time. Less time that you notice. So you don't notice, you go, that's already running. Why? Because it's run. That's what should happen. What happens now? Ding, loading modules and stuff and working on stuff, okay. It should be on instantly. There's no question we can make that happen. However, how do you get things to run fast? Run less code. Okay, so I'll tell you about run less code later. Shareable components, enhanced isolation, resource management. These are things we could do with JVM support, and I'll give you examples, okay? The other thing is the free unicorn. Because when I talked to Dan about this, he said, that sounds great, we need all that. He goes, what are you going to do after you promise that? Give them a free unicorn too? Because everyone's going to go, you can't have this. You can't, it's impossible. This is going to be, you know, so the unicorn is a dream. That's why you're imagining this, because this is something we have to build, okay? So what do you need for this? You need, you know, some sort of cooperation from the VM to help you load classes, and load them faster than running arbitrary Java code between the JVM and the actual class. So what happens today is every time I load a class, and I'm really excited about it, I have to call some whack of Java code. That's what the JVM does. The whack of Java code is either code that then calls me again, so that's fast, so it doesn't waste, or it calls a huge installed class loader chain of stack of stuff that's adding value and time. And because it's runtime, I can't predict what it's going to do. I can't cache it. I can't repeat it. I just have to say, you know that class I asked you for 1 million times over the last 1,000,000 years? Where is it? And you say, let me check. Rummage some code around, and oh, here it is. And I can prove it's exactly the same place, but I don't know that's where it'll come from. So I have to let you tell me where the class is. That's where it breaks in terms of extreme performance. So what I think we need to do, and this is implementation details, and if you're an OSGI user, you don't care about the implementation. There's probably 6 people in this audience who cares about the better class loader. Although if we do a better class loader, there won't be any talks on how to do thread context class loading. Who gave that talk this week? Someone gave that talk for sure. You shouldn't have to know this stuff. And OSGI, you don't need to know about class loaders, you just need to know you're getting the benefit, and it happens to be class loaders leak out a little, okay? But what happens if the class loaders could actually run, predict what's going to happen, tell the VM, hey, this is good until a dependency changes. And I go, great, I'm going to follow these pointers and load it, bang. And when I load it, bang, I mean one read, it's in memory, I'm already running, okay? That takes Eclipse startup in my ideal universe to sub-second, maybe 700 milliseconds, which is what you should be able to do. Sounds good, right? And not 25 seconds, which is what my machine currently does. So does this mean we need a new modular, a new module system, new modularized everything? No, what we need is to take what we have and improve it so that all the stuff we have continues to work and it works better. That's the story, okay? And the last one, so I'll talk a little bit more about the kinds of things we could do with the JVM. But since I'm up here and I can complain about stuff, this is part of the mocking phase, remember? I'm not even done the solutions phase. You guys have to fix errors. Now this is something from, I guess Peter Creans had a blog entry and said, and so when I talked to a bunch of guys, I said, that's not Eclipse. That's Felix, those guys are clowns, so don't trust those guys. So I said, fine, Google is my friend. This is what happens when you look at class loader problems. And what I like about this one is, I shouldn't drop this because then I have to go back to my thing, is first of all, I have no idea what to fix here, other than there's one thing I don't like, is between me, I'm Java-lang class loader, and the huge stack above is code I don't want to run every time I load a class. That's my point. That's a lot of code for loading one class. I can do it fast, but I can do it faster if I don't have to call the code. That's not my point here. My point is this poor soul. I don't know what to do. You just feel sad for him. Don't you feel badly about doing this to this guy? You should. So simplify or you're not going to get the success we need. Okay, the adoption. Okay. So now that we stopped mocking, let's go do some pot of golding. Okay? So first of all, there's an innovation problem, I think. I think that we're not driving fast enough. You saw my laundry list? It's pretty long. We should be driving innovation and doing the kinds of experiments that would prove those things out, whether they're done within the core JDK or whether they're done outside. right? OSGI actually proved that you can do really great innovation without being part of the core. You can continue that and push harder, okay? So, but the rate and pace isn't going to wait for Java. So as a Java person, I'm like, oh, gee, there's all these crazy things happening, crazy stuff. You know, why isn't Java going as fast? Why not, right? And so I think there's no single answer, but I think the industry needs, the Java industry to stay healthy, needs to up its pace. And it's not just up to Oracle and not just up to IBM, it's communities like Eclipse, which actually drive as much or more innovation, if you look at the projects that are happening at Eclipse, than the rest combined, except the rest is OSGI, so I didn't mean to say it that way, but I'll just drink here quietly. But my point is, you built a lot of great stuff, but we can't rest on that. What have you done lately is what happens to me every day when I go to work and say, did you see our benchmark results? Yeah, what are you doing tomorrow? What do you mean, they're great? No, what are you doing tomorrow for your customers? Like, so what have you done lately is not good enough. So we invented this is not an answer. We invented it. What are you inventing next is the answer, okay? Otherwise, your technology will just be gone. And that's true for both OSGI, it's true for things like Eclipse. And Eclipse is doing great stuff like Orion, right? Things are moving to the web. Got to take a look at Orion if you're ever going to do web tooling or web runtimes on how that's going to work. Actually looks a lot like the integration stuff for Eclipse, so there's great stuff happening there. OSGI is pushing into things like cloud. There's proposals for multi-tenancy. There's lots of great stuff, so we have to keep it up. The thing I hate, and so I put this on here because it's my talk, is everyone goes, Java's dead because you have to be compatible. Right? Oh, you can't break apps. You can't. So I want to take that one on. You can't. Right? So I'd like to talk about some solutions, and then we'll have a great day at the conference. So I want to talk about, well, if I get them all in, the only one I want to get to is discussions at the bar. So if I skip any charts, it's because I'm trying to get to the last one. And we'll be meeting there at 10:02. Truthfully. Anyways, compatibility is the one I want to talk about because people say, oh, you're going to break compatibility. Like, we should have a technology solution for that. Okay, so I'm going to talk about these and talk about the problem. So the compatibility is that two-edged sword, or double-edged sword, depending on how you like to say it. It's been a key strength, and we have to protect our customers' investment. The problem with compatibility is supporting it eternally. All this code that was written, and I see it. Some clown in some division in some unnamed company I might work for, I was going to say who, but now it just calls me and says, this is broken. You say, like, what is it? I don't know, it's some binary WAD we don't have the source for that was compiled back in 1997. Java 1. Whatever broken release that they used, and they still use it, or they're not sure they don't use it. Either way, it's in the thing and it's causing some sort of problem. And you're like, right? And it still runs, it's just something's a little bit weird. So we're like, it's awful. The problem is it drives special use cases. It's a myth that the JVM hasn't changed. The JVM does all sorts of crazy stuff under the covers. It either fixes security problems, breaks compatibility except when you're in a certain mode, blah, 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 blah. So there's lots of things we do to ensure compatibility. Apparently, though, it's hard. So this is from the Eclipse, Eclipsepedia, I guess. Here's how many ways you can keep compatibility. And I think there's 10. And here's how many ways you can break compatibility. And there's 15. All right? Now, Eclipse tools on the left, these are operations they optimize by giving you tools to do this. Okay? So 2/3 of, or more, 15 out of 25, whatever that works out to. 3, you know, another third more, half more, depending on how you count. Of the operations in Eclipse break compatibility if you use them on APIs that you want people to rely on. You can just do stuff and hose everybody. That's why things break. Who actually writes code that they assume will be compatible next release? Who thinks it's hard? Yeah, well, there you go. This is proof. So we need to get rid of some of these. So how do you deliver compatibility? I can talk about it in the context of versions and OSGI modularity, okay? So the issue is compatible with what? If you don't have a version or an ID or something to be compatible with, what are you being compatible with? I don't know, some previous version, I don't have versions, or some previous thing, some blob I had on my disk that I don't know what's in it. Why? Because I don't know what it is. So you have to have versioning. That's a critical thing to be compatible. And this version information, oh, look at all this stuff, is really nice because you can do what I have at the bottom, the thought experiments. What if I only run versions 2.0 and higher? Can I do better? Can I optimize? Okay, so we're going to talk about those. And what if they don't use things like variable x being a thing that you shouldn't use? So more imagining. Imagine things like if you wanted to do API evolution using versioning and dependency analysis to help you, but specifically versioning, to help you say, what am I being compatible with and how do I fix it so that it can remain compatible and make what otherwise would be a breaking change, right? So I'm going to take you through some code very quickly. Sorry for this, but imagine you made a bad choice. How do you know? You called your variable bad field. All right. Imagine you want to use the Java mechanism. I know I should have used an annotation, but I'm trying to invent syntax so that you don't focus on the bogus way to do it, and you're making it a language thing, not a... So imagine you were able to declare it deprecated, and I have some new things in v2. So I have two comparisons. Now, we all know that v1 clients compiled against v1 will run against v1, and they'll run against v2, except that when you compiled, you should get a warning. And then there's v3. This is the ideal one. Took me 3 tries. I got it right. And notice, no bad fields. How am I going to be compatible now? Well, notice the other line, which I'll show you. Same line, so don't get too excited. It's a new line that said, I deprecated between v1 and v2. So anyone in that range is good to go. You have to do something to make that work. But anyone else, and the doing in this case, I said map it to get field and set field. So it's a trivial example, don't get too excited. But what I did was I said, I'm allowing you to remove a field that was public and mitigate. So I could deliver better compatibility by leveraging the fact that I have versions and I know what's in there to say, oh, if I'm a version 1 client and I'm a v3 implementation over here, I actually map that field to something new. Okay? So that's for free. Eclipse could read the v3 mapping and go, not only do we map it, we modified your source for you. You're welcome. Right? So it starts to make it easy. I don't mind breaking people's code if it doesn't cost them anything. As you loaded Eclipse, your code's been upgraded. Thank you. Run. Still works. That's what you want, right? You don't really care that the field's gone. You want your code to work. So you could do this. Now, what about the social engineering aspects? Right now, you remove a deprecated method, and it means nothing. It's just a suggestion. What you could do here is you could then have a convention that says after 2 releases, it's gone. Binary stuff we can make work, but it's really gone. So I'm future-proofing my implementation because I'm allowed to change it. So this is a way to give more tools to developers to break code or evolve their APIs and still provide compatibility. So that's how you have to think if you're going to drive innovation and changes that maybe are not even on the table today. Okay? So the social aspect is the first time you get a warning and the second time you get an error. There's no source-to-source compatibility in Java. Matter of fact, it's really easy to break source compatibility, and when you change generics and other things, all sorts of stuff breaks. But you're changing your code anyway, move it up. Some of the transforms are automatic, and others would require developer to change things. And so this is an idea on how you could do it. It's not the only idea, but it's a way. Okay. So let's talk a little bit about Java 8. And the first one I just wanted to say is Java 8 is, it's going to have Lambdas. That's about the only thing in the release. The only reason to mention that is they're doing what I just said, but for interfaces. So right now, in JSR 3.35, you can add a method to an interface. What happens to implementers of that fine interface? They're all broken. They're missing that method. So interface evolution is impossible. That's why you have interface 1, 2, and 3 names in your classes. And then somewhere down there, you cast a ramma into the one that you might be able to use because it has the extra stuff, and you see if it's an instance of one of those. So it's really horrendous. Here, they have a way in Lambda to add a method. If they're going to force you to implement this new method, but you don't have it, you get a free one. Now, that breaks a little bit of the shiny interface has no code thing, but it allows you to evolve your interfaces and not break code, which is exactly the kind of thing Java needs. Okay. So modularity, well, it's moving to Java 9. Gives us more time to influence and get it right. I think the kinds of things we're going to talk about, if I get through it, is the kinds of things that Jigsaw should have. And the ones I want are primitive operations. This is class loaders on steroids. Okay, so the kind of thing that you'd want to make loading fast. And make sure the architecture separates the concerns for user space modularity systems, which can, by necessity, do a lot more specific things. And not all those things should be in the JDK. So you can't break, solve the JDK's problem and break everyone else's problem just to solve something that actually doesn't really need to be solved at the moment. Okay. So this is just an ad for Penrose. For OSCI implementers, which there's a few in the audience, the way we're doing this at OpenJDK is we have a project. There's a developer mailing list for collaborators, which is licensed in a way that you can actually work there and still do your implementations at Eclipse. Okay, you don't have to go and dig in the Jigsaw code base. We have a separate mailing list for folks who want to understand but not have GPL worries, which is frankly a lot of people do. And so the way to, basically this is here for us, IBM leads this, to make sure that we get all the requirements we need for the Jigsaw stuff, if it goes ahead or as it evolves, to make sure OSGI is still a first-class member of the runtime. So that's, if you're an OSGI implementer, or if you have use cases you think are interesting, you can check out Penrose. Okay? So the one thing I wanted to talk about before we run out of time is an opportunity for OSGI. So by moving modularity out to Java 9, I guess Oracle invented execution environments. They called them profiles to be sneaky, but we all know what they're really called, execution environments, subsets of the SE runtime. And guess what? Your tools already support them, and they're smaller and lighter weight, which is what I want. Because I want to say, hey, run bind tools on my WAD, which is, my code. And all of a sudden, it says, oh, you can only run on compact 1 or 2 or 3. These are 3 different profiles that are being proposed. You can imagine if your application, instead of the download having to be 60 megabytes, it was 8. Because you only use the left-hand side. Because we know you only use it. You're module users. We know what your dependencies are. We can do the analysis. And you can actually code to it to prevent yourself from what we call coloring outside the lines. And saying, oh, it'd be really great if I used a Java X transaction here. What for? Oh yeah, to get 30 more megabytes, I forgot. You don't want that. You want to be able to stay within the lines unless you actually decide to go further, which is why bind tools is okay, but you should manifest first, come on. That's all I will say about that. All right, so reminder, this is why we do this. And I'm just going to switch. So this is something I showed at Java 1. I want to drive to this 10K, that very rightmost, 10K per application. Or imagine 10K plugins for Eclipse, where you could actually run for separate users. So if we move Eclipse onto the server side, which is part of some of the Orion, how Orion is implemented, some of the stuff that was written for Orion is this Eclipse running in the cloud, essentially. And if you wanted to make that multi-user, you're not going to have an instance per user. You're going to want to multi-tenant that baby up because it's going to be too expensive otherwise. So in this case, what we do is we support one copy of the code and multiple copies of the data. So you can isolate same code, multiple data, right? And since we're good children, we share. The other thing we do is we start to put things in the shared classes cache. And so bytecodes and JITted code, and you get things like 20% memory reduction, 30% startup. Pretty nice. It's not really what I'm here to talk about, but it's really nice. But here's my life. 500 JVM start at the same time. Guess what they all do? They all fork on a 1024 core machine. They all fork 1023 GC threads. They all do a bunch of setup, and then they go madly and overcommit that box 500 ways, because it's just a big contended mess. And so anything I can do to make that less load will get me up faster, 30% faster on our current stuff, based on the fact that all the JIT code was there last time. So the way you tell people is, why would I compile object 20 times? Or in this case, 500 times? Why would I recompile class 500 times? So the just-in-time compilers are great, but if I have to make my own copy every time, I'm going to lose. So a lot of that kind of stuff. Well, I wanted to talk about OSGI in that context. Okay? So I want to share code. I want to share resources. The way to do that is to make things cacheable. So, but let me just talk about this one. Actually, it's a little bit. The key to sharing, from my perspective, is identifying what version do I have, and that way I can tell you, hey, that's the same thing. I know I have a 1.0, I saw it. And I know 1.0 means something, it's not just a file name. So I can load, point to the same code, give you your own variables, and now I have a solution that runs fast. Okay? So for multi-tenancy, the interesting thing about OSGI is that you have some sort of model for thing. It's called a bundle. You can add behavioral things to that bundle. It's a way you ship application ship code. You could say, I'd like to be able to load this in a multi-tenant environment. Could you provide a single copy of the code, multiple copies of the variables, and some lifecycle events, which are critical, attached to a tenant, detached from a tenant. Eclipse could use it for load a plugin, unload a plugin, and I want my own, at least resource managed plugins. So you out of control plugin, shoot it, right? Instead of recycling Eclipse. Of course, if you have instant on, you just recycle. So maybe it's not needed. So what you need, and I won't go through all the cases, other than the fact that we were reinventing a kind of thing called a DLL, in case you didn't know. But DLLs with more dynamicism. The D is a fake in a DLL. It's not very dynamic. It's just load and go. And it's not very interesting. But for OSGI, dynamic really means something. So what you really want to do is leverage lifecycle and things like the versions to be able to determine exactly what is already in the system and reuse it. Okay? So when EE systems were starting to build using OSGI, they started to get shared components and reduce the footprint. This could help us go even smaller. Okay? So I have a little example right now. You can do this with class loaders. Class loaders are evil. Don't let anyone tell you different. Multiple copies of the code, lots of duplication. And remember, duplication is expensive when you multiply by 1,000. And that's how many instances of JVMs we run on cloud machines now, and they're getting bigger. Okay? So this is a way that we've added isolation to the JVM. It's kind of a lot of technical detail, but I can say per variable whether to share it or not. So it's very fine-grained control. You wouldn't have to worry about that. You would say, hey, bundle, could you please be loaded in a way that's multi-tenant? So all of a sudden, a way for you to write multi-tenant apps supported with a life cycle, okay? And the JVM support would be there to isolate your state and isolate it fairly well, okay? So in this case, there's some JVM magic that splits the static out. But for you, it's just, I'm loading my application. If my app server supported multi-tenant mode, it would just run in multi-tenant mode. It would say one copy of the code, multiple tenants. What does multi-tenant mode mean? I could shoot one of the tenants and the rest of them stay up, even in the same JVM. Right? Kind of critical if you're going to run 1,000 tenants in a JVM. Now, you can shoot the whole process, everyone goes down. So there is a cost, right? There's an isolation trade-off to get multi-tenancy in a single JVM, but you're willing to do it for certain classes of apps. Not everything runs that way, okay? So the other one I was going to call out is what I call dynamic behavior. So this is when you run on a hypervisor, VMware, AX Power VM, any of those hypervisors, it's actually lying to you. It says you have this many cores, you have this much memory, and then actually takes it away or adds more later. It depends. It just, the rules change depending on what the system's being, how it's being managed. So we call it the layer of liars. The thing is, right now, there's no way for you to deal with that in Java. So what we've done is we've added JMX events, and if you wanted to, you could take these things, read them, and adjust. What would happen if you were doing this behavior with, excuse me, a little more dynamically? Well, my view is you could do it intelligently. Okay, so you have bundles already. Okay, so you want to be able to say, if I have a bundle and I might respond to a particular kind of event, memory resize. Maybe my bundle is something that would be able to do something smart with that. Maybe it's not. Maybe just say, I don't know what to do with this. But maybe you have buffer pools. Maybe if you have a lot of memory, you have more buffer pools. But if you have less, you're willing to shrink down in size. So this is additional life cycle events, but it's not quite, it's sort of a life cycle, but it's a dynamic kind of behavior. In OSGI, the bundle would be a great way to do this because you have a scoping mechanism. For this bundle says, I have a mode that supports a lighter weight runtime, or lighter weight, you know, when I get less virtual CPUs, for example, if I get less cores attached to my process, then I might give away some thread pool, right? So these are all excellent ways to extend OSGI. We already know how to start and stop, and so I listed some: attached, detached tenant. I think I said that earlier. Wouldn't you like to know that you're being attached to a new tenant? What would you do at that point? Well, if you're writing an HTTP service, maybe, you might want to not use some hard-coded IP address. You might gonna ask, what's the IP address I'm being brought up as, right? Might be, right? Because each one might have to pretend it's a different host. Or you might say, I don't know, open a different database connection per tenant and manage it that way, right? For every tenant. And you could share that state and not share the databases. Okay? The other ones, I think I mentioned, actually live migration. So what happens now is if you have an application that's running, it's pounding away, and someone says, this machine's going down for service. They just grab it and move it to another machine. Now, that could take minutes, which is a problem if you're in a hurry. But I liken it to carrying a screaming child who's trying to fight you. Okay, that's what the JVM's doing. It's dirtying pages, it's making lots of messes, GCing. If you're trying to move an application, the more dirty pages you have, the more expensive it becomes. So you don't want to do that. So if you said, hey, you're moving house, what do? Leave everything lying around and wait for the movers? No, you put it in boxes. You stop making messes in different rooms. You prepare to move, then you move, and then you reopen all your stuff. So cooperative kind of cooperation with things like other layers and a communication channel, an organized way to do it is actually a great way to increase performance. So for example, we can get at least 2x on our migrations now by cooperating. All right, I have no time, but luckily I have no charts. So let me just talk about, I talked a lot about what we could do in the JVM, and I can't really go into super detail, although I put some code up there to talk you through it. You know, come and see me. I'll be here. Just come and see me if you want to actually talk about stuff. If you have great ideas, VM, you're always listening. But let me just point out one thing. It's a community effort. I don't think rate and pace of innovation Java community is fast enough. Matter of fact, it just isn't, right? We have lots of serious problems. There's lots of stuff going on. We should move faster, and we need to cooperate. So it has to be, you know, Eclipse, Apache, and yeah, even OpenJDK, where we are working on Java based with Oracle. So IBM and Oracle were able to get together and work together to make Java better. And there's communities in this room that could also help, certainly around modularity and the discussion there and how the right way to go forward is. Constructive interaction. And I think, in terms of today for cloud, I could talk about some of the other languagey stuff, but for cloud, because you already have this great model that knows about versions, knows about dependencies, there's a bunch of great things we could do to optimize your runtimes, a bunch of great things we could do for making them smaller, making them faster, making them, I was going to make up a word, evolutionable, I think is the word, but you can evolve your software in some strange way that was going to break most of your clients, except that you have a way to mitigate. And that's the way we're going to break free from the everyday argument I have where I can't change something because someone says it's going to break something. It drives me crazy Because if you could just, if you could just change that one thing that one guy in one place uses, it's literally some of these features, you just don't know who uses them. It'd be really nice to know that too. So, the code recommenders guys, if they could tell me where, in the Eclipse project, they could tell me who uses what and where, that would be awesome. Because when they code recommend, they give you the highest ones. I want to know the lowest ones. Who doesn't use this? Come on. All right. So cloud, compatibility, performance, and software engineering discipline paying dividends. That's payback for actually spending the time to modularize your application. If you do that, you should benefit by having your application start in 0 time and deploy significantly faster. And that's what the JVM guys can help you do. That's why I was here. So, behave, share more, use less, cooperate, don't exploit your children. Thank you, and I'm done for today. So, thank you very much.